We use metals in our daily life, from furniture to cars, trains, airplanes, all the way down to our buildings and even large infrastructures such as bridges. We are highly reliant on metallic materials. As such, there is a continuous effort to come up with better metallic materials that are more sustainable, that are easier to develop, and that are cheaper. Also, with the world evolving and a secure supply chain becoming more and more important, new manufacturing routes such as metal 3D printing is going to be more and more important. My research basically looks at how we can make better metallic materials that are more sustainable, they come at a lower cost, and they give us better properties. I achieved this while looking at new manufacturing routes such as metal 3D printing, or optimizing more traditional manufacturing routes such as forging and rolling, or sometimes developing totally new materials. To do physical metallurgy in a state-of-the-art way, one needs to look at the microstructure of materials, from macro scale all the way down to an atomic scale. And we are lucky here at Imperial and also through the ROIs and other national facilities to have access to some really advanced characterization equipments. If we can make our metallic parts lighter, we can save not only on materials, but also on energy. For example, if we are going to use that part in a car or an airplane. If we can make our materials processing a bit greener, there are significant environmental benefits with it. And if we can help make 3D printing a more mature manufacturing method, then there is a greater scope for making really complex parts much faster and customized for a particular application. A game changer in making airplanes more efficient is to make them lighter. And in the context of materials that are used in engines, this usually means using materials that work better at higher temperatures. For this, we need to work both on the alloy design and the manufacturing. Also, with the current shift to electrical vehicles or those that are powered by hydrogen, we need to rethink how we design the structure of cars and the alloys we use. We now have great capabilities such as AI that can help us towards better solutions, but also advanced characterization facilities that we can harness to study the micromechanisms behind the behavior of materials, all helping us coming up with new ideas for structural applications, but also for materials that are going to be used in extreme environments.